You are working on something important, and suddenly the screen freezes. One tiny error brings everything to a grinding halt. Traditional computers are built like a single fragile chain. If one link snaps, the entire machine stops working because it doesn't have a way to step around the break. Currently, the only way to fix that break is for a person to manually search through millions of lines of code and type out a correction by hand. But there is a different way to build. Imagine technology that acts less like a fragile machine and more like a helpful household member, staying invisible and reliable while you focus on your family. This shift starts with a new foundation called Sovereign OS. Sovereign OS is designed to be indestructible because it places every task into its own separate, hardened container. If one program encounters an error, it stays trapped in its own bubble, so it can't pull the rest of the system down with it. By creating a digital home that is physically unable to crash, we finally have a stable floor. This is the necessary first step before we can introduce a system that learns to look after itself. Sitting safely on that stable floor is the Omega engine, a central digital brain that coordinates everything the computer does. This brain removes the need for you to learn specialized coding commands. Instead, you just tell it what you need, using the same plain English you'd use to talk to a friend. To carry out your request, the engine looks through the Atomadic Lattice. This is a massive library of pre-made blocks, where each block is a perfect, indestructible bit of logic. The engine selects the exact blocks required and fits them together to build a functioning program instantly. Because these blocks are pre-tested and designed to fit together exactly, the software it builds is solid and reliable from the very first second. By using these precise logic blocks instead of manually typing out instructions, the system translates what you want into a finished, working application without the usual bugs. What if you ask for something new that lacks a pre-made block? The engine identifies the space and grows a custom block. For older parts, it automatically ejects the weak link and slots in a fresh version. To make sure the computer doesn't make a mistake while repairing itself, every update has to pass through a strict safety checkpoint. This digital immune system scans the new part to ensure it is healthy and fits perfectly with the rest of the system before it's allowed to connect. This creates a one-way street for quality. The system follows a strict rule where it can only accept a change if it makes the overall code stronger or more efficient than it was before. This combination of self-repair and constant safety checks means the system is always quietly fixing its own errors, often before a human would even notice a problem existed. When the computer takes over the job of maintaining itself, it leaves us free to just use the technology, like a parent and child exploring a new lesson without any interruptions. This same self-healing ability can support a doctor managing patient records or a community organizing its local resources, ensuring their tools never let them down. In the background, the logic blocks of the lattice are constantly shifting and updating, making sure everything stays secure for every user. It's a complete system, an indestructible foundation, a digital brain to coordinate the work, and a library of perfect building blocks. We are moving away from the era of fragile machines. We don't need to learn a specialized language to talk to our computers anymore, because our computers have finally learned how to grow and heal on their own.